Fine. So let us see what we mean by indexing in database systems. So what is the basic concept of indexing? Usually, the indexing mechanisms are used to speed up access to desired data. Many times it happens that our database systems are storing huge amount of information. Even one relation is having millions of records, right? And whenever we want to extract the data from whenever we want to extract the data from these huge relations, so whenever we are extracting the data from huge relations having billions of records stored in one relation, what we are expecting is whenever we submit any search query or whenever we submit any query, we want to get the immediate response for our query, right? So obviously we want to expedite, we want to speed up the access to the desired data, right? And that is why we are having here the concept of indexing, simply to speed up the processing, to speed up the search, to speed up access to desired data. So few examples of indexing are index of a book or author catalog in library. So let me give you one example of index of a book. All of you must have used index of our books. So if you refer to any of the books, if you refer to any of the books, you may find one index of that book, and usually typically the index of the book is at the end of the book. So see here, this is the index of our database systems book by Korth and Sudarshan. So if you look at the last pages of the book, you will find such kind of index. So what is mentioned in the index? In this index, usually the key terms are being listed in some sequence. The key terms are being listed in some sequence. So usually in the index of the book, the key terms are listed in alphabetical manner. Right? So see here, the terms are being listed alphabetically. What else has been listed here in this index? See here, along with a particular term, say for example, just look at this entry in the index, alter table. So associated with this entry of the table, alter table, we are having here two numbers. And these two numbers are actually describing the page numbers where you can refer this term, alter table. So if you directly go to this page number 63, or if you directly go to this page number 129, it is possible for you to see or to read the contents related to this alter table. Right? So this is a use of index. So we may search these key terms according to the alphabetical list. So we may find the term that we are intending for. So we can locate that term, and with respect to that particular term, we are finding out the page numbers where the associated text is available. So directly we may jump to that page and we may read the content. So no need to go page by page to seek for the desired content. And that is why we are having index in every book. Right? Are you getting me? Yes?
Yes, ma'am.
Fine. So this index actually helps us to expedite our search for a particular content in the book. Right? So similar is the use of index in our database system. So in our database system, we are having collection of huge data, and every relation is having billions of tuples. So if we want to go to a particular record, or if we want to search for typical data from the relation, then it should be possible for us to expedite the access, right, to that particular data. Right? So the indices in the database systems are maintained. So in database systems, we are having a search key. So what is a search key? A search key actually is a single attribute or the set of attributes. Those are being used to look up the records in a file. Right? Now, we are having a separate index file which consists of the records of the form search key along with a pointer. Right? Say for example, if I am having the instructor table. In our instructor table, we are having 4 attributes: ID, name, department name, and salary. Right? So these are the attributes that those we have. So we may have the index for this instructor relation, right, based on one or more attributes of this instructor relation. So let us assume that our search key is ID. It is a single attribute. Let us assume the search key is ID, right, which is a single attribute. So what I will have in my index? I will have this search key along with a pointer that points to that particular search key value. Right? So in my index file, I will be having a search key. Say for example, if I am having the ID 12121, right? Then 13131, something like that. Then I am maintaining these search key values in my index, and associated with every search key value, I will be having a pointer. So that pointer will directly point to the record that I am looking for. So if I want to search for a particular record, I will be referring to the index, right? And based on that index, I will directly jump to a particular record in my instructor relation. right? So if I'm creating the index for a relation, as I've stated, we are having a separate index file associated with that index for that particular relation. But these index files are typically much smaller than the original file size. So my original file size or my original relation is huge because it stores lots of attributes related to the instructor. But in my index file, I'll be storing simply the search key value along with a pointer. So size of my index file is much smaller than the original file size or the original size of the relation. We are having two basic kinds of indices. So what are those two basic kinds? The first kind is known as the ordered index. So in ordered index, the search keys are stored in sorted order. So see, for example, if we are building the ordered index for this instructor table with respect to the attribute ID, then my search key values are being stored in the order of IDs, right? If I'm creating the index for instructor table based on this name of the instructor, then my search key value will be name of the instructor, right? And if I'm having the ordered index, then all the names of the instructors will be ordered because name is my search key. So all the names of the instructors will be ordered in my index file, and associated with every name of the instructor, I'll be having a pointer, right? So in my ordered index, search keys are stored in sorted order. The other kind of index that I may have is the hash index. So in hash index, we are having search keys. Those are distributed uniformly across the buckets using a hash function. So in building hash indices, we are making use of a mathematical function known as the hash function, right? And this hash function is computing some address based on the search key. So based on that computation, it will provide me the address of the block. This block is known as bucket, right? So this hash function will provide us the address of bucket or the block where we are going to store the record related to that particular search key, right? So two important kinds of indices: ordered indices and hash indices. Ordered indices are maintained in the sorted order of search keys, whereas in hash indices we are having a hash function. This hash function is computed based on the search key value, and accordingly the records are distributed uniformly across the blocks or buckets. So I hope you must have understood this concept of indexing, how index file is associated with each index that we are having for the respective search key of the relation. And there are two important types of indices: ordered indices and hash indices. Is there any doubt so far? Yes? Is there any doubt? Please pick up. Yes. Have you understood the concept of index?
Yes, ma'am.
Fine. So let's go to the index evaluation metrics. As I stated, we are having variety of indices available. Even though we are having these two important kinds of indices, ordered indexing and hash indexing, under these two categories, we are having several different ways which we may use to maintain the index. Now, if I'm having several ways to maintain the indices for our database systems, then we need to identify which kind of indexing technique is suitable. So if we are having multiple options, we should have some criteria to select the best option, right? And that is why we are having the index evaluation matrices, or rather index evaluation ways, metrics, right? So what are those index evaluation metrics? We are having access type, we are having access time, insertion time, deletion time, and space overhead. So based on these four parameters, our index type or our indices are being evaluated, and whichever index type is most suitable for the database or the relation under consideration, that particular index is being selected. Okay, so let us look at those parameters. The first is access type. So what we mean by access type? So whenever we are building the indices, we need to think of which access types are supported by that kind of index efficiently. Meaning, finding the records with a specified value in the attribute. If I am having such kinds of queries, or if I am having other kinds of queries, say for example, finding records with an attribute value falling in a specified range of values. So let me give you the examples of these two kinds of queries or access types. So in the first access type, we are finding the record with a specified value in the attribute. What we mean by that? Suppose I am having the instructor relation, right? And what I want to find out the instructor with ID equal to 12121. So I am finding record with a specified value in the attribute. So this is my search key ID, and I am looking for a record with a particular ID. So that is one kind of access type, right? In another kind of queries, we may find the records for those fall within certain range of values. What does this mean? Suppose I want to find out the instructors for which the ID is greater than say 10,000 and less than say 20,000. So here I am giving the range of value. Right? So what I want to search for the instructor records such that the ID is greater than 10,000 and the ID is less than 20,000. Right? Or I may need to find out the records of instructors belonging to, say, particular department. Right? So we are having these different access types wherein we are finding a particular record with specified value in the attribute, or we are finding the records providing the range of values. Right? So which indexing mechanism is more beneficial for searching the records with specific value, or which kinds of indexing mechanisms are more useful if we are having range queries? If we want to extract the records, those belong to specified range of values, right? So these are the access types. So some indexing mechanisms are good for first access types. Some mechanisms are good for the second kind of access type. So depending on the access type, we may select a particular indexing mechanism. Now, the second criteria is access time. So what we mean by access time? If we are searching for a particular record, then what is the time required to get that information, to get that record? That is the access time. So this access time actually includes the time required to locate the record and the time required to read that record and to return that record, contents of that record to the user, right? So this is actually the response time. So access time is the time required to locate the particular record and to get the information of that record, right? Similarly, the third criteria is insertion time. So if we are inserting a record into a relation, the time required to insert the record in the relation. So this includes, once again, the time that is required to find the appropriate place to insert the record and actually the time required to insert the record. Okay. Similarly, we are having deletion time. So if we want to delete a record, what is the time required? So once again, this time includes the time required to locate the record that we would like to delete and the actual time that is required to delete that record. Okay. Next is the space overhead. As I stated, associated with every index, we are having the index file. So obviously, some space is required to store this index file. Right? So that is the space overhead associated with indexing. So always, if we are creating the index, we need to store that index in separate index file. And this index file also requires some space. Right? So that is the space overhead. But let me tell you, if we compare these two tasks, one, we want to expedite access to the data, and another task is another attribute is the space required to store that index file. Obviously, we are more inclined towards accessing the data quickly. And nowadays, we are having ample space available. Right? So space is not an issue nowadays. And that is why we may prefer to go for indexing, even though it requires some space to store that index, because ultimately it is possible for us to expedite access to the data by making use of these indices or those index files, right? So these are 5 important metrics based on which we are actually evaluating the type of index. In the next class, we are going to talk about the ordered indices. What are different types of ordered indices, right? And then we will proceed for hash indexing, right? So in the next class, we'll be focusing upon ordered indices. And please remember, these indices are really very important while building the database applications to expedite our access to the data, right? So let's conclude today's session. Thank you.